Good morning, students. Welcome back to chemistry class. Today we are going to study about the equivalent mass of gram equivalent mass of acids, bases, salts, oxidizing and reducing agent. Okay, and then what is the relationship between mole concept and then gram equivalent concept? Today we are going to study. Okay, so please listen carefully, take notes. Okay, then only you can understand. Okay, simple notes you have to take. Okay, students, in last class we studied the gram equivalent mass. Okay, what is the definition for the gram equivalent mass? The mass of an element that combines or displays 1.008 gram hydrogen or 8 gram oxygen or 35.5 gram chlorine. Using this definition, we have calculated the gram equivalent mass of zinc. Okay, one of the elements zinc that displays the hydrogen. Okay, displays the hydrogen to form the zinc sulfate. We have calculated yesterday, but today we are going to study how we can calculate the gram equivalent mass of an acid or base or any other substance. That substance cannot react or combines or displaced the three standard elements that are 1.008 gram hydrogen or 8 gram oxygen or 35.5 gram chlorine. Okay, so if we want to calculate the gram equivalent mass, the definition is mass of an element that combines or displays 1.008 gram hydrogen or 8 gram oxygen or 35.5 gram chlorine. Okay, so that element should reacts with the hydrogen or oxygen or chlorine or displays hydrogen or oxygen or chlorine. Then only we can calculate the gram equivalent mass. Okay, suppose other elements, okay, that cannot reacts or cannot combines or cannot displace the hydrogen or oxygen or chlorine. Okay, that particular substance we can calculate the gram equivalent mass by using one of the formula, that is gram equivalent mass is equal to molar mass. Molar mass, molar mass, what is the unit of molar mass? Gram per mole divided by equivalence factor. Equivalence factor, that is, what is the unit of equivalence factor? Equivalent per mole. Okay, so we can calculate the gram equivalent mass, okay, using this formula. So here in your book, calculation of gram equivalent mass of acids, bases and oxidizing and reducing agent given in your book. How we can calculate? Let's see. First upon, the gram equivalent mass of acids. Okay, gram equivalent mass of acids. Here, what is the formula we are using here? The molar mass, gram equivalent mass is equal to molar mass divided by equivalence factor. Okay, so here molar mass, you know, molar mass means the total mass of molecular mass of an element. Okay, the molecular mass of an element, mass of 1 mole of element. Mass of 1 mole of element or molecule, that is the molar mass. Okay, and the equivalent factor, what do you mean by equivalence factor? Equivalence factor is equal to basicity of acid. Okay, here if you are calculating the gram equivalent mass of acids, what is the formula we are using? Molar mass divided by equivalence factor. Here equivalence factor, okay, here if you are calculating the molecular mass, gram equivalent mass of acids means here what is meant by equivalent factor is equal to basicity of acid. Basicity of acid, that is the equivalent factor, that is small n. Okay, equivalent factor, that is small n. It means the basicity of acid. Understood? So the basicity, what do you mean by basicity? What do you mean by basicity? Basicity means the number of moles of number of moles of ionizable H plus ions present in 1 mole of an acid. Okay, what do you mean by basicity? Number of moles of ionizable H plus ions, number of moles of ionizable H plus ion present in 1 mole of an acid. Okay, so what do you mean by number of ionizable ions, that is H plus ions, that is acid means H2SO4 example, and H3PO4 and HCl. Okay, the example for the acid. Okay, so acid means it must present the H plus ion. Understood? So what do you mean by basicity of acid? What do you mean by basicity of acid means how many H plus ion present. Okay, so if you are taking the H2SO4, if you are calculating the gram equivalent mass of H2SO4, okay, equivalent mass of H2SO4, here how much ions are present here? Hydrogen ions are present, 2 H plus ions are present. 2 H plus. So it undergoes ionized. Okay, it can ionized. How it is ionized? H2SO4 it ionized into 2 H plus SO4 2 minus. Okay, so how much ions are present here? 2 H plus ions are present. Okay, so here what is the basicity of acid here? How much basicity having here? 2. Okay, so here what is the equivalent factor for the H2SO4? If you are calculating the equivalent mass of H2SO4 sulfuric acid means we should know the equivalent factor. What do you mean by equivalent factor? What do you mean by what is the formula for using gram equivalent mass? Gram equivalent mass is equal to molar mass by equivalent factor. What do you mean by equivalent factor here? Okay, what do you mean by equivalent factor? Using the acids, that is basicity of acid. What do you mean by basicity? Number of moles of ionizable H plus ion present in 1 mole of an acid. That is the basicity. Okay, so let's calculate the gram equivalent mass of H2SO4. Okay, so here gram equivalent mass of H2SO4 sulfuric acid. So what is the formula? E is equal to equivalent mass is equal to molar mass of an acid divided by equivalent factor. Instead of equivalent factor we can write basicity of acid. Understood? Okay, so here how much basicity having? 2. Number of ionizable H plus ions are how much? 2. Okay, so basicity here, basicity of H2SO4 here 2. Basicity of H2SO4 2 equivalent per mole. Understood? This is the basicity, or otherwise called as equivalent factor. Okay, understood. So what is the formula we are using to calculate the equivalent mass? Equivalent mass is equal to molar mass of acid by basicity of acid. Okay, molar mass by basicity of acid. So what is the molar mass of acid here? Which acid we are using here? Sulfuric acid, H2SO4. How can you calculate the molar mass? So here molar mass is equal to how much hydrogen we are having here? 2. You know the atomic mass of hydrogen 1. Okay, plus sulfur. You know how much sulfur atoms are having? Only 1 into what is the atomic mass of sulfur? 32. Okay, yesterday I have written the atomic mass of some elements. You should study that. Plus, how much oxygen are having here? 4. 4 into what is the atomic mass of oxygen? 16. 4 into 16. So totally 2 plus 32 plus 4 is 16 into 4. 64. Okay. So totally 98 gram per mole. Okay, this is the molar mass of sulfuric acid. Okay, so equivalent factor, the basicity equivalent factor, otherwise basicity of acid is 2 equivalent per mole. Okay, so what is the gram equivalent mass? The gram equivalent mass of acid is equal to molar mass of acid divided by basicity of acid. Okay, basicity of acid. So, molar mass how much? 98 gram per mole. What is the basicity of acid here? 2. 2 equivalent per mole. Okay, so mole and mole you can cancel. So here the 98 divided by 2, we can cancel the 98 by 2, we get 49. Okay, 49 gram per equivalent. This is the gram equivalent mass of an acid, sulfuric acid. Okay, gram equivalent mass of sulfuric acid. Okay, and the next, how can you calculate the gram equivalent mass of bases? Okay, bases. So what is the formula we are using here? Gram equivalent mass is equal to molar mass divided by equivalent factor. Okay, molar mass and gram per mole. This is the unit, and equivalent factor equivalent per mole. Okay, understood? So here, what is the equivalent factor here? Okay, so we are going to calculate the equivalent gram equivalent mass of bases. Okay, so here equivalent factor means acidity of bases. Acidity of bases, that is N, small n. Acidity of bases means number of ionizable OH minus ions present in 1 mole of base. Okay, the acidity of bases means number of moles of ions, number of moles of ionizable OH minus ions, number of moles of ionizable OH minus ions present in 1 mole of base. Okay, here we are going to calculate the gram equivalent mass of KOH. It is one of the base. You know, base means the OH minus ions present in any compound, that is the base. For example, NaOH, sodium hydroxide base, calcium hydroxide, CaOH twice base, magnesium hydroxide, MgOH twice. These are the bases. Okay, so here we are going to calculate the gram equivalent mass of KOH. Understood? So here, what is the acidity of base here? OH minus ion. Okay, so KOH we can, how ionizable KOH? K plus plus OH minus ions. How many moles of ionizable OH minus ion having here? 1 mole. Okay, 1 mole. Understood? So what is the equivalence factor here? 1 equivalent per mole. Equivalent factor means here acidity of base. Okay, acidity of base means here 1 equivalent per mole. Okay, acidity of base 1 equivalent per mole. So what is the formula? Gram equivalent mass is equal to molar mass divided by equivalent factor. So here molar mass divided by acidity of base. Okay, so what do you mean by molar mass? Molar mass means molecular mass. Okay, the mass of substance present in the 1 mole of molecule. Okay, 1 mole of molecule, amount of substance present in the 1 mole of molecule here. For the KOH molecule, what is the molar mass? Potassium, you know, how can you calculate the molar mass? We should add the atomic masses of every element present in the given molecule. Okay, so KOH, K, potassium, what is the atomic? We should know the atomic masses of element, then only we can calculate the molar mass. Okay, so some important elements, atomic mass, I have already yesterday class, last class, I have written and give. Okay, study. There is potassium, atomic mass of potassium 39. How much potassium atom having? Only 1 mole. So 1 into 39 plus oxygen, only 1 mole. 1 into what is the atomic mass of oxygen? 16 plus hydrogen, you know, 1. Only 1 atom having hydrogen atomic mass 1 into 1. So what? 1 into 39, 39 plus 16 plus 1. So what is the gram? So molar mass of potassium hydroxide 56. We are adding this. We get 56 gram per mole. Okay, 56 gram per mole. This is the molar mass of KOH. And so what is the equivalent mass? Gram equivalent mass is equal to molar mass of base by acidity of base. So molar mass here 56 gram per mole. 56 gram per mole divided by what is the acidity of base here? 1. Okay, 1 equivalent per mole. So this mole inverse and mole inverse we can cancel. So remaining 56. Okay, 56 gram per equivalent. This is the gram equivalent mass of KOH. Understood? And then, okay students, now we are going to study about calculate the gram atomic mass of oxidizing agent or reducing agent. How can you calculate the gram equivalent mass of oxidizing agent or reducing agent? Here in your book only oxidizing agent only given. Okay, understood. So here before that you should know about what do you mean by oxidizing agent, what do you mean by reducing agent. Okay, what do you mean by oxidizing agent, what do you mean by reducing agent? You should understand clearly first. So what is the formula for calculating the gram equivalent mass? Here gram equivalent mass is equal to molar mass by equivalent factor. Okay, here for the oxidizing and reducing agent means the gram equivalent mass is equal to the molar mass of oxidizing agent or reducing agent divided by number of moles of electrons gained or lost by 1 mole of oxidizing or reducing agent. Number of moles of electrons gained or lost by 1 mole of the oxidizing or reducing agent. Very, very important. So you don't know about what do you mean by oxidizing agent, what do you mean by reducing agent, you don't know. Okay, so listen carefully. What do you mean by oxidizing agent? Okay, so oxidizing agent means one of the substance, it oxidizes the another substance itself undergoes reduced. Oxidizing agent means it oxidizes another substance and itself undergoes reduced. Okay, so reducing agent means it reduced another substance and itself undergoes oxidized. Okay, so oxidizing agent means one of the substance, it oxidizes another substance. It oxidizes another substance, that is called oxidizing agent, but itself undergoes reduced. Okay, like that, reducing agent means it reduced another substance, but itself undergoes oxidized. This is the definition for the oxidizing agent and the reducing agent. Okay, here, what do you mean by oxidation? What do you mean by reduction? Oxidation means very, very important. Everyone please take notes. What do you mean by oxidation? Means loss of electron. In your lower classes you studied about that. Okay, oxidation means loss of electron, reduction means gain of electron. Oxidation means loss of electron. Reduction means gain of electron. Okay, understood. So here we want to calculate the gram equivalent mass. Okay, what is the formula? The molar mass of oxidizing or reducing agent by number of moles of electrons gained or lost by 1 mole of oxidizing agent or reducing agent. Okay, so here for your book only the oxidizing agent example only oxidizing agent only given. Okay, so we can calculate only oxidizing agent. So what is the formula we are using? Gram equivalent mass of the oxidizing agent, the gram. Okay, if want to calculate the gram equivalent mass of oxidizing agent like potassium permanganate. Okay, what is the example for the oxidizing agent? Potassium permanganate, KMnO4. Okay, and H2O2 you studied clearly about that. H2O2 is the one of the oxidizing and reducing agent. Okay, both oxidizing and reducing agent, that is hydrogen peroxide. But KMnO4 only oxidizing agent. KMnO4 only oxidizing agent. Okay, understand? KMnO4, what is the function of KMnO4? KMnO4, it is one of the substance. It can oxidize another substance. It can oxidize another substance and itself undergoes reduced. Okay, so what is the function of KMnO4? It undergoes a reduction takes place. Okay, in the KMnO4. And understood what do you mean by reduction? Gain of electron. Okay, so it always gain electron. KMnO4 gain electron. Okay, it oxidize another substance. So another substance lost electron and that electron KMnO4 gained. Understood? So that is the KMnO4 is oxidizing agent. So what do you mean by oxidizing agent? It can oxidize another substance and itself undergoes reduced. Okay, what do you mean by reduction? Reduction means gain of electron. Gain of electron. Understand? So here, what is the gram molecule? How to calculate the gram equivalent mass of potassium permanganate? Gram equivalent mass of KMnO4. KMnO4, that is one of the oxidizing agent. So, what is the formula? The molar mass of oxidizing agent divided by the equivalence factor. Okay, here what is the equivalent factor? Here equivalent factor means the number of moles of electrons gained. Okay, here only oxidizing agent only we are calculating. Okay, suppose we are calculating the reducing agent means what do you mean by equivalent factor? Equivalent factor means number of moles of electron loss. Okay, number of moles of electron loss by 1 mole of the reagent. Okay, the number of moles of electron loss by 1 mole of the reagent. Okay, that is the reducing agent. Okay, but we are oxidizing. We are studying about the oxidizing agent. So what is the equivalence factor? N means here number of moles of electron gained. Okay, so the gram equivalent mass is equal to molar mass of the oxidizing agent. It is gram per mole divided by number of moles of electron gained. Okay, there is equivalent per mole. Understood? So first upon how the KMnO4 is oxidizing agent we are going to study. Before that we should we want to calculate the molar mass. Okay, you know how to calculate the molar mass of KMnO4. You know KMnO4 molar mass how to calculate. We can add the atomic masses of element present in the molecule, KMnO4 molecule. So molar mass is equal to KMnO4 means K, potassium atomic mass 39. So how much atoms are have? Only one atom, so 1 into 39 plus manganese how much manganese atoms have? Only one manganese, so 1 into what is the atomic mass of manganese? 55 plus oxygen, how much oxygen? 4. 4 into, what is the atomic mass of oxygen? 16. Okay, so if you are multiplying and adding this, we get 158 gram per mole. This is the molar mass of KMnO4, potassium permanganate. Understood? So this the KMnO4 is one of the oxidizing agent. Oxidizing agent undergoes reduced. Okay, so in acid medium, the KMnO4, it reacts only in acid medium because it's one of the oxidizing agent. Okay, understood? So in acid medium, potassium permanganate reduced. Okay, so how it is reduced? So KMnO4, you know, KMnO4, it can ionize to form K plus MnO4 minus. Okay, MnO4 minus. So the MnO4 minus, how it gain the electron, we are going to study about. Okay, so we have to calculate the equivalent factor. Equivalent factor means here the number of moles of electron gained. So KMnO4 is one of the oxidizing agent. KMnO4, it gained the electron. Okay, understood? So MnO4, it undergoes gaining of electron. Understood? So MnO4, it gets reduced to form Mn plus. Okay, Mn2 plus. The MnO4 minus, it gets reduced to Mn2 plus. How it gets reduced? Because here 4 oxygen atom having. If 4 oxygen atom it is present in the reactant side, the opposite side, if we want to balance this reaction, here 4 oxygen atom having, so to balance the oxygen atoms, the 4 water molecule we should add. Understood? So then only oxygen is balanced. Understood? So 4 oxygen atom here, so 4 water molecule we should add the opposite side. Understood? So here 4 oxygen atom balance, but here hydrogen atom, how much hydrogen atom here? 8 hydrogen atom having. So we the opposite side hydrogen atom we have to balance, so 8 H plus. Understood? So we have to, now the elements are balanced. Now the manganese 1 atom, so here also 1, oxygen here 4, here also 4 oxygen, hydrogen here 8, here also 8 proton. Here we have to balance, the elements are here balanced now, but here we have to balance the electrons, number of electrons we have to balance. Okay, for that we should know the oxidation state. Here you should know the oxidation state. Okay, here the MnO4 minus and the Mn2 plus. For the MnO4 minus, we have to calculate the oxidation state of manganese in MnO4 minus. Okay, how you calculate the oxidation state? For that, you should know the oxidation state of some common elements. Okay, so oxygen, what is the oxidation state of oxygen? You know, oxygen atomic number 8, so electronic configuration 2,6. To attain the stable configuration, the oxygen, it always gain 2 electrons. Okay, so the oxidation state, the valence of oxygen here 2. So oxidation state of oxygen here minus 2. Okay, minus 2, because it gain electron, it always gain electron, so minus 2 extra electron are having in the oxygen atom. So oxidation state of oxygen is minus 2. Understood? So here we have to calculate the oxidation state of manganese. So one of the formula, for example, I am telling one of the formula. For example, only suppose we want to calculate the oxidation state of A in AB molecule. What is the formula? A plus B is equal to 0. Okay, so Okay, so if you want to calculate the oxidation state of A in AB minus molecule, so what is the formula? A plus B is equal to, what is the, here only one charge have minus charge, so minus 1. Okay, understood. So suppose if you want to calculate the oxidation state of A in AB plus means is equal to A plus B is equal to plus 1. Understood. So this is the formula to calculate the oxidation state. Here we want to calculate the manganese in MnO4 minus. Okay. So how you can calculate? So Mn want to calculate the oxidation state of Mn manganese. So the Mn we have to take as X. So we don't know the oxidation state of manganese, so we have to take it is X plus how much oxygen having? 4 oxygen. So 4 into what is the oxidation state of oxygen? Minus 2. 4 into oxygen, 4 into minus 2 is equal to, what is the charge here? Minus 1. Okay, so it's equal to X minus 4 into 2, 8. X minus 8 is equal to minus 1. Okay, so X is equal to the minus side is going to the after the equal to, so it gets plus. Okay, so 8 minus 1, so X is equal to plus 7. So this is the oxidation state of manganese. Okay, so X is equal to manganese. So what is the oxidation state of manganese here? Plus 7. So reactant side manganese or is the oxidation state minus 7, sorry, plus 7, but the product side oxidation state of manganese 2 plus. Okay, plus 2. Okay, understand? So we have to balance the charge. Here 5 electrons are less here. Plus means electron lacking, electron deficiency. Okay, how much electron deficiency here? 5 electron. Understood? So you know the KMnO4 is one of the oxidizing agent. So oxidizing, what do you mean by oxidizing agent? Oxidize one of the substance, it oxidizes another substance and it itself undergoes reduction. Reduction means gain of electron. So MnO4 it always gain electron. So plus 5 electron it gained. Understood? Understand? So this is the, so how much electrons here? Added 5 electron. Okay, understood? This is the equivalent factor. What do you mean by equivalence factor here? What do you mean by equivalent factor? Number of moles of electron gained. Okay, so this is the one of the oxidizing agent. Oxidizing agent, it always undergoes reduction. So reduction means gain of electron. So what do you mean by equivalence factor? That is number of moles of electron gained. How much number of moles of electron gained here? 5 electron. So here equivalence factor N is equal to 5. Understood? So here, so what is the our formula? Gram equivalent mass is equal to molar mass of oxidizing agent. So here oxidizing agent KMnO4, what is the molar mass? 158 gram per mole divided by number of moles of electron gained. Okay, how much number of moles of electron gained? 5 electron. 5 gram equivalent per mole. Okay, so mole inverse cancel. So what is the 5 divided by 158 divided by 5? We get 31.6 gram per equivalent. Understood? This is the gram equivalent mass of potassium permanganate. This is the gram equivalent mass of potassium permanganate. What? 31.6 gram per equivalent. Understood? Friends, now we are going to study about what is the relationship between gram equivalent mass concept and mole concept. Okay, what is the relationship between mole concept and gram equivalent mass concept? Okay, so according to mole concept, it requires the balanced chemical reaction. Okay, it requires the balanced chemical reaction to find out the amount of reactant involved in the chemical reaction. Okay, so the mole concept required the balanced chemical reaction. Mole concept require the balanced chemical reaction, the reactant side and product side. The balanced reaction we want. Okay, but as per the gram equivalent mass, according to gram equivalent mass, it does not require the balanced chemical equation. Okay, so it does not require the balanced reaction. Only the gram equivalence bond. What do you mean by balanced? The gram equivalence mass, gram equivalent mass, it is the mass of the given substance combined. Okay, mass of the given substance combined with or displaced a fixed amount of another substance. That is the gram equivalent mass. Okay, so but mole concept, we require the same mass. Okay, the balanced reaction we need. Understood? The gram equivalent mass we does not need. And next one, the mole concept, it prefer to the non-redox reaction. Okay, mole concept is preferred to the non-redox reaction, but gram equivalent concept, it is preferred to the redox reaction. Okay, already we studied about that redox oxidizing and reducing agent. We can calculate the gram equivalent mass of the oxidizing and reducing agent. Okay, oxidizing, what do you mean by redox? Redox means both oxidizing and reducing. Okay, so the gram equivalent mass, it is suitable for the redox reaction, but it is a mole concept, it is suitable for the non-redox reaction. This is the relationship between gram equivalent mass and mole concept. Gram equivalent mass and mole concept. Okay, now one example, I will explain now. So first upon the one of the reaction, we take one of the reaction. So it is, what is the relationship between mole concept and a gram equivalent mass only we are going to study. So one example. So KMnO4, potassium permanganate, we know it is one of the oxidizing agent. So it is preferred to the gram equivalent mass. Okay, so it is preferred to the redox reaction. It is preferred to the redox reaction. KMnO4, one of the oxidizing agent. Okay, so if we know the equivalent mass of KMnO4, and anhydrous ferrous sulfate, without writing the balanced chemical reaction, we can straight away say that how much gram of the potassium permanganate need to react with the ferrous sulfate. Okay, one of the reaction react with the KMnO4 and ferrous sulfate. Okay, KMnO4, it is one of the oxidizing agents, so it is preferred to the redox reaction. This is the oxidizing reaction, so the reducing reaction, and ferrous sulfate is the non-redox reaction. So we can apply here mole concept. Okay, so here what is the gram equivalent mass of potassium permanganate? We know, if we know the gram equivalent mass of the potassium permanganate, we already calculated, that is 31.6 gram. Okay, so the ferrous sulfate, what is the mole? 1 mole ferrous sulfate, how much weight, how much mass having? So ferrous, we know the ferrous atomic mass 56 into sulfur 1. There is one sulfur atoms are having atomic mass 32, so 1 into 32 plus oxygen 4 into 16. So we get 152 gram. Okay, so the 31.6 gram, 31.6, this is the gram equivalent mass. Gram equivalent mass of potassium permanganate, it reacts with the 152 gram of ferrous sulfate. Understood? So this now we are telling this using the gram equivalent concept. Okay, without writing the balanced chemical reaction, we can tell that 31.6 gram need to react with the 152 gram of ferrous sulfate. Okay, so is it correct? Okay, let's check it is correct or not by using the mole concept. Okay, so the same can be explained on the basis of mole concept. Mole concept need the balanced chemical equation. Understood? The mole concept need the balanced chemical equation, but gram equivalent mass, we cannot need the balanced chemical equation. Straight away we can tell this, if we know the equivalent mass. So if we know the equivalent mass of the substance, straight away we can tell how much amount of substance react with this much amount of reactant. We can tell. Based on mole concept, we have to write the balanced reaction between the potassium permanganate and ferrous sulfate. We can write. So the potassium permanganate, you know, the potassium permanganate, that is KMNO4. It react with FeSO4, ferrous sulfate. So it is potassium permanganate is one of the oxidizing agents. So this reaction takes place with it in acidic medium. Acidic medium means one of the sulfuric acid here reacts. Okay. So here the KMNO4, it is one of the oxidizing agent, you know. The KMNO4, it oxidizes. What do you mean by oxidizing agent? Oxidizing agent means it oxidize another substance and itself undergoes reduced. Okay, understood? So here this KMNO4, it oxidizes the ferrous sulfate. Ferrous sulfate means Fe2 plus. Okay, so it oxidizes the ferrous sulfate. So we get it convert to ferric. Ferrous sulfate converted to ferric sulfate. Ferric sulfate means Fe2SO4 thrice. Ferric sulfate. This ferrous sulfate, it is converted to ferric sulfate. Fe2SO4 thrice. And we have to remember this when the potassium permanganate react with the ferrous sulfate. Potassium permanganate, one of the oxidizing agent, it can oxidize the ferrous sulfate. Okay, so when the ferrous, it can convert to ferric. Okay, so that time the manganese, it accept the electrons. Okay, so the manganese, it converted to manganese. When manganese react with the sulfate to form manganese sulfate, and then potassium also react with the sulfate to form the potassium sulfate. Okay, and hydrogen also having, so we get water molecule also. Understood? So what is the product we get here? The potassium permanganate, it oxidizes the ferrous sulfate. So ferrous, it is converted to ferric. Okay, so FeSO4 is converted to Fe2SO4 thrice. Okay, so manganese also react with the sulfate to form manganese sulfate, and the potassium, it also react with the sulfate to form potassium sulfate. The formula potassium sulfate K2SO4. Okay, and water. Now we have to balance the equation here. Here potassium, we know 2 potassium atom having, so we have to make here 2. Then only potassium balanced. And manganese here, now manganese 2. So the product side we have to make here 2. So understood. So this and then we have to balance the sulfur, sulfate, hydrogen also. Okay. So the potassium and manganese balanced here. The sulfate here, how much sulfate atoms are having here? Totally 3 plus 2, 5 plus 1, 6. Totally 6 sulfate molecules are having. But here you have to remember one thing. One number you have to remember. Okay, one number you have to remember. That is 5. Okay, 5 molecules of ferric sulfate we got. 5 molecules. You have to remember this one number. We can balance all the substance, we can balance now. So 5 means the 5 2s. Okay, ferric sulfate means 5 2 iron. 5 2s are 10. So 10 iron having here. So we have to make here 10 iron. 10. Then we have to balance the sulfate molecules here. Here how much sulfate molecules are having? 5 3s are 15 plus 2. 15, here this one sulfate, 15 plus 2, 17. 17 plus 1, 18. Totally 18 sulfate molecules are having. But here only 10. Okay, 10 sulfates only having. So we have to get the 18 sulfates. We have to make here 8. Okay, 8 sulfate. Okay, so here also, here 18 sulfate, here also 18 sulfate. The hydrogen also here A2s are 10 hydrogen also having here. So here also 8 hydrogen. A2s are 16, A2s are 16 hydrogen. Understood. So oxygen here 8 oxygen, so 4 2s are 8 oxygen here. The equation is balanced now. Okay, understood. So here 2 moles, how much moles of potassium permanganate? 2 moles of potassium permanganate. Potassium permanganate molecular mass already we have calculated, that is 158 gram. Okay, molar mass. So the 2 moles of potassium permanganate, that is 2 into 158 mass. 158 is equal to 316 gram. Okay, 316 gram of potassium permanganate react with 10 moles of ferrous sulfate. 10 moles of ferrous sulfate means 10 into, what is the molar mass of ferrous sulfate? 152. 152 is equal to 1520 gram of ferrous sulfate. Okay, so what is the equivalent mass of ferrous sulfate? How we can calculate the equivalent mass of ferrous sulfate? So the total mass of ferrous sulfate here 1520 divided by the potassium permanganate, how much mass? 316 gram potassium permanganate into, what is the equivalent mass of potassium permanganate? 31.6. So if we are dividing and multiplying this, we get 152 gram. Okay, 152 gram of ferrous sulfate we get. Understood? So this is the relationship between mole concept and equivalent mass concept. So here okay, students, take page number 10. Page number 10, evaluate yourself. The 2 questions are having. If you can do, try to do these 2 questions. Okay, if you can do, try to do this. Okay, if you cannot do this, no problem. After we will discuss about this later. Okay, and today's our study portion, page number 123. The question number 39, 40, 41, 42, 43, 44. The 6 questions are having. You should study. And send me through my WhatsApp number. Okay, students, thank you.